Hello everyone, let's go ahead and work through solutions to the problems assigned out of section 5.4. So first up, we're just supposed to change an exponential statement to the equivalent statement involving a logarithm. And really the only important thing to remember here is the basic identity that when a to the x is equal to y, this is equivalent to x is equal to the logarithm base a of y. So we just have to identify what's what here. So here we have a base of 3, an exponent of 2, and a result of 9. Just linking up the number that is being raised to a power, that's our base. The power it's being raised to, that's our exponent. And the result on the other side, that's what we're calling our y. So with this choice of a base x2 and y9, we can just say the equivalent logarithm is the logarithm base a of 9. Sorry, not base a, base 3. The logarithm base 3 of 9 is equal to 2. So similarly, we identify that our base is 9, our exponent is just x, and the result is 9.3. So the equivalent statement is the logarithm base 9 of 9.3 is equal to x. Now we just go the other way. We have the logarithm base a of 2 is equal to 6. And remember, if a to the x is equal to y, the equivalent logarithmic statement is that x is equal to the logarithm base a of y. So here we actually have the logarithm. So we identify that our base is lowercase a, our y is 2, and the x, which will be the exponent, is 6. So the equivalent statement as an exponential is that a to the 6th is equal to 2. Let me just clarify, this isn't a 9. My writing just got a little sloppy. This is a. All right, the only thing here is to recognize that the natural logarithm means the logarithm whose base is the natural base e. So that's what we have here. So converting this, the base to the exponent equals the result. That's all. All right, change things up. Now we actually want to find the value of logarithmic expressions. So what I'm going to do, I'm actually going to set this equal to x, and we're actually going to be able to find the value of x. So if we change this to an exponential expression, we get 4 to the x is equal to 1 over 64. Now 1 over 64 is 1 over 4 cubed. In other words, it's 4 to the minus 3. And on the left, we still had 4 to the x. Okay, so we've been able to change the expression we had to 4 to the x equals 4 to the minus 3. Now just remember, exponentials are 1 to 1. And what that means is that if 4 to the x equals 4 to the minus 3, x must have been equal to minus 3. Similarly, okay, this just means the logarithm whose base is e of the 6th root of e. I'm going to set this equal to x. Now if I convert this to an exponential, we get the base to the exponent is equal to the result. Just remember that this notation means e to the 1/6 power. And now I have e to the x equals e to the 1/6, and since exponential functions are 1 to 1, I conclude that x must equal 1/6. So we want to solve this for x. Well, since I have a logarithmic expression, we could try changing it to an exponential. 7 to the 2nd power equals x, and we're done. X is 49. Very straightforward. Similarly, I convert this to an exponential. 2 to the 5th is equal to 2x plus 6. Now 2 to the 5th, let me just count that off on my fingers. 2, 4, 8, 16, 32. Equals 2x plus 6. If I subtract 6 from both sides and divide by 2, x is 13. All right, now we have something a little bit different. or so it would seem, okay? In terms of understanding our exponents, This is the natural logarithm of e to the x. What it doesn't refer to is the natural log of e to the x. Okay. What's understood is that the x exponent is properly attached to the e that it's next to, not somehow a log of e. Okay, so if we have the natural log of e to the x is equal to 8, remember that just means the logarithm base e. If I convert this to an exponential, we get e to the 8th is equal to what we were taking a logarithm of, which was e to the x, and since exponentials are 1 to 1, x must equal 8. All right, now we want to solve this equation for x. Now, when we've done problems like this so far, we were able to express the number on the other side as a power of the number on the left. Okay. Now, it's not quite as obvious how we're going to do this. However, what I can do is I can change this into a logarithmic expression. Okay, so 3x plus 8 is the logarithm base e of 10, which we will write as the natural log of 10. Now, what's important to remember is that the natural log of 10 is just a number. I don't know off the top of my head exactly what number it is, or even approximately what number it is. I mean, I expect it's about 3, but I don't know exactly what it's equal to. It doesn't really matter. It's a number. So what can I do to numbers? I can add, I can subtract, etc. So if I subtract 8 from both sides, we get 3x is equal to whatever this number was minus 8. And now I can divide by 3. So whatever the natural log of 10 is, I subtract 8 and then divide by 3, and that will be what x must be. Note that this problem said write the answer in terms of a natural logarithm. We did not want to do a decimal approximation here. This is the proper result. All right, the log base 3 of x squared plus 2 is equal to 4. Let's convert this out of a logarithmic and into an exponential expression. So 3 to the 4th is equal to x squared plus 2. 3 to the 4th is just 81. I can subtract 2. And therefore x is plus or minus the square root of 79. Now, logarithms do not have a domain of all real numbers. Okay, the domain of any logarithm is positive numbers, because remember, logarithms are inverse functions to exponentials, so the domain of a logarithm is the range of an exponential, and exponential functions have a range of positive numbers. Therefore, logarithms have a domain of positive numbers. So we want to be sure that we actually have two distinct solutions here. So let's just check, are both of these in the domain? Well, if I convert, sorry, not natural logarithm, logarithm base 3. If I try to plug either one of these in, I'll have the logarithm base 3 of 79 plus 2. That's fine. I could continue computing, but I don't really need to. I'm just checking, is this even legitimate? 79 plus 2 is definitely positive, so this is in the domain. Now, if x is negative root 79, I end up with the logarithm base 3 of still 79 plus 2. Remember, a negative number squared is still going to be positive. So negative root 79, when I square it, is still going to be 79. So this is also in the domain. Okay, so these are both in the domain. And therefore, here are our two solutions. So here we have 5 times e to the 0.5x equals 14. There are a couple of ways we could do this, but I can't convert this into a logarithmic expression directly because the left-hand side is not just a base to an exponent. It's being multiplied by 5. So let's get rid of that by dividing by 5. So e to the 1/2 x is equal to 14 over 5. Now I can convert this to a logarithm. So 1/2 x is equal to the natural logarithm of 14/5. Now I can multiply both sides by 2 and get x is equal to 2 times the natural logarithm of 14/5. There's no need to check anything regarding domains because we started with an exponential expression, the domain of which will be all real numbers.